Hey, welcome to Meverse Education. Today, we're looking at negative and zero exponents and what those mean. All right, so let's get into it. First, let's start with 8 squared times 8 to the negative fifth. Negative exponent. We haven't quite seen those yet. So what does that even mean? Well, if we try to add these, let's see what happens. Because this is what we've done before when we used the product property. We have 8 to the second plus negative 5, which is 8, which is really, you can write that as 8 to the 2 minus 5, which is 8 to the negative 3. Okay, what does that mean? Okay, well, let's check this out. Negative exponents represent the inverse of the base. The inverse is not the opposite, but we're going to flip it. So 8 to negative third becomes 1 over 8 to the third. And you're only taking the inverse of the base. Okay? And that's important. That's probably the biggest mistake that I see with students is that when they see a negative exponent, they want to take the inverse of everything, but it's only the base that's connected with that negative exponent. Okay? So, let's check out something else. The negative exponent represents the inverse of the base. And again, that inverse means flip. And I put it on here again because I want to show how it works in different scenarios. We have 2 to the negative 8 like we just saw before. We're just going to flip it over to become 1/2 to the 8th. 1/2 to the 8th. Or 1 over 2 to the 8th power. Alright. But what if that negative exponent's in the denominator? Well, take the inverse, so we're going to flip it. 1 over 12 to the negative fourth becomes 12 to the fourth. Because that 12 to the fourth is really 12 to the fourth over 1. But we just don't really put divided by 1 because it doesn't change anything. Alright. Now we're going to use this and start looking at 0. Alright. We got 9 to the 7th times 9 to the negative 7th. These both have the same base. So that means we can use the product property. So we have 8 to the 7th plus negative 7th, which is 8 to the 7 minus 7th. 7 minus 7 is 0. So we have 8 to the 0 power. Okay, now, well, what does that mean? Okay, let's look at this a different way. 9 to the 7th times 9 to the negative 7th. If you remember, negative means do the inverse, and we're taking just the inverse of that base, so it becomes 9 to the 7th divided by 9 to the 7th. Hey, we divide something by itself, the same thing. 9 to the 7th divided by 9 to the 7th, the same thing you're dividing. It's 1. Alright, so what we just learned just now is that the zero exponent, anything raised to zero exponent, is 1. Okay? Again, I'm going to reiterate that. Any base to the 0 power is 1. Any base. It can be 10 to the 0 power is 1. Negative 8 to the 0 power is 1. 1 to 0 power is 1. And all these craziness. Any base to the 0 power is 1. Okay? Any. But only the base. Not anything else attached to it. Alright. Let's look at something else here. 5 to the 7th power times 9 to the 0 power. Again. Only that base gets turned to 1. So 5 to the 7th times 1, which is 5 to the 7th power. That was easy. Sweet. Alright. What about 8x to the 0 power? This is where I get people messing up. Only the x becomes 1. Because that 0 exponent is with the x. It is not with the 8. Okay? So we got 8 times 1, which is 8. Alright? So, only that base, it's any base with the 0 exponent becomes 1. Nothing else is being attached to it. Okay? So, if you want to see more examples like this or see what we're doing at Meverse Education, visit us at meverseed.com. Thank you for watching. Hope you have a great day. Adios.